We're not going to use this formula here. I just placed it in the wrong place. Well, yeah. When I was making or rearranging the PowerPoints. So for this example number 3, we're still going to use the formula future value is equal to present value, parentheses 1 plus R over M to the power MT. And remember that the book also has this other alternate form in which R over M is equal to I and M times T is equal to N. So those two are just equivalent. Okay, so let's go ahead and see what quantities we have from the problem. And it says that if 16,000 savings account grows to 50,000. So right there we have a present value, which you can think of it as the past value, but we call it present value because that's what was originally invested. So present value is 16,000, and then we have a future value is going to be 50,000 because that's what the account grows to be. And the time will be 18, and it's already in years, so we just need the integer 18. And now our question is going to be, what is the interest rate? And so right here, it's also important to notice that, well, that was the question. What was the interest rate? But also here we have annual compounding. So from there, we could also get that M is equal to 1, the number of compounding periods. So now when I take my formula, I don't like what I did, so I'm just going to undo that. Let's just leave it there. So once I take that formula, that one, and then I substitute the quantities that I have, and in this case we have the future value is 50,000. We have the present value, it is 16,000. We also have the rate. No, actually that's what we're looking for. Sorry. That's what we're looking for, the rate. And we do have the number of compounding periods. It says annually. And we also have T, which is the time. And that was a total of 18 years. So I'm going to substitute those quantities. And future value is 50,000. Present value is 16,000. And then we have parentheses 1 plus R over 1 because it's compounded annually. And then we have M times T, and for M we're going to use 1, and for T we use 18. I'm going to rearrange some of the terms here. So I'm going to have 50,000. This 16,000 is multiplying to everything inside the other parentheses. So it makes sense that if I take it across, it's going to be dividing. And now here we have parentheses 1 plus R, because we just have R divided by 1, and then we close the parentheses, and if we multiply here, we just get 18. Here I can just cross the zeros or divide by 1,000 on the top and bottom, and we have 50 divided by 16. We could also reduce that because 50 could be divided by 2. 16 could be also divided by 2, but we're going to leave it like that as a fraction. And now I want you to think, how would you undo the 18th power? And think about the similar way that you will undo a square. You will take the square root to cancel that out. So we're going to take the 18th root on both sides. And that will cancel here because they're inverse operations. So now we just have 1 plus R. And on this side, we're going to have the square root, not the square, my bad, 18th root of 25 over 8. And so to find the answer, this will be the 18th root of 25 over 8. and then minus 1. Why minus 1? Because this positive 1, we take it across and it will be subtracting on the left side. So to enter it on the calculator, you could do the following. You could open parentheses, enter the fraction 25/18, close the parentheses, then you will use the caret symbol, and that will be the fraction 1/18, or 1 divided by 18. And then you will have to use the arrow, the right side arrow, just so that you're outside of the exponent quantity, and then you will enter minus 1. So you don't want the minus 1 to be part of your exponent. You want it to be outside. So after entering that, you should get a rate of 0.06535, and as a percent it will be 6.535%, because we have to divide by 100, so we move the decimal point 2 units to the right. Now, last class, we introduced a little bit of what happens when the number of compounding periods is different. And here we had annually, quarterly, semi-annually, monthly, and daily. So we discussed that in class. We had 1 for annually, 2 for semi-annually, 365 for daily. And then here for quarterly, we have 4. So when we calculate I, which is R over M, it will be the interest rate that we had found here, 0.0085, divided by quarterly, which is a 4. And we're just going to leave that as a parenthesis. Now we're going to calculate it for I for monthly. So this will be R over M as well, which is going to be 0.0085 divided by 12. So when we use our formula, we're going to do the following. We're going to use this formula, by the way, future value, because that is the question. Find the value of the account of 10,000. So actually, let's write down some of our variables. So for all of these, what we're looking for is the future value. And for all of them, we know that the present value is going to be here, 10,000. We also have that the rate for all of them was the same, 0.0085, because it was 0.85%. Also, we have the money invested for 1 year, so T is equal to 1, and that's all we need so far. So we're going to use this formula. Future value is equal to present value parentheses 1 plus R over M, close the parentheses, and then M to the power T. So we're all looking for future value, so we're going to use the 10,000 as the present value because that's the money that was originally invested. And then here we're going to have 1 plus, and then, for example, to calculate the one that is annually, we will have R over M, which is 0.0085 over 1. And for the exponent here, we will have 1 multiplied by 1 because it's compounded annually, so that's M. And T is also 1 because the problem says that only for 1 year. So we're going to enter it like that on the calculator, and then I will show you how to copy paste it so that we can calculate every single other compounded period. And so what we're going to do with the calculator is copy paste, and then we're going to go back and change the quantities that will represent the period the number of compounding periods. This will remain 1 because it's 1 year. So we're going to be changing here M and M according to what the problem is asking. So to enter this on the calculator, it will be 1,000, the present value, parentheses, 1 plus, then I'm going to use another parentheses to enter the rate, 0.0085, and then divide it by, for annually, it will be 1. Then I'm going to close the parentheses there just to enclose R divided by M. Then I have to close again to close the parentheses that is before the number 1. Then I'm going to use the caret symbol, and inside the exponent, I'm going to enter 1 times 1. I know this is not really necessary, but I need that, so when I copy paste, those numbers are still located there. So I get that for annually. And now what I'm going to do, and I see a problem here. I'm sorry. It's not 1,000, it should be 10,000. That was my problem. So the future value should be $10,085. Now to copy, you're going to use the up arrow. If you click it once, it highlights the answer. If you click it again, it will highlight the problem that I enter. Remember, I changed it for 10,000. So I press enter, and it's going to paste it on the next row. Now I'm going to go back there and change that compounding period into a 2, but I'm not going to press clear. I'm going to press delete. And I'm going to put a 2 for semi-annually. Then I'm going to go back here, delete, and press a 2. And then enter. That would be the answer for semi-annually. We rounded to the nearest cent because we're talking about money. Now I'm going to copy, and then I'm going to go back using my arrow, go back to the left, press delete, and now for quarterly we change that to a 4, but we also have to change it here. Do not press clear, only delete. The answer for quarterly is there. Then I'm going to copy that question again, press enter, and now I'm going to calculate monthly. So I'm going to change that 4 for a 12, but also here. And make sure that you don't delete any of your extra or double parentheses, because then the calculator will not know what to do. Now we're going to go for the last one, which is daily, and we're going to change that 12 into a 365.